Namaste. So myself, Dr. Naik. I take engineering mathematics 1. So as we know that you're all engineers, the basic knowledge of mathematics is very essential. So it's like for a building, we need a strong foundation. If you have a strong foundation, then you can build any structure above that. Like that, if you have a strong basic knowledge in mathematics, definitely you can have any engineering application on that. In that manner, we have to learn engineering mathematics. So in the first semester, we have 6 chapters in engineering mathematics 1. The first chapter is first unit. It is matrices and determinants. Second unit, it is vectors. Third unit, it is probability and logarithm. Fourth unit, it is a trigonometric base, allied angles and compound angles. Basics of trigonometry you have learned in SSLC. After that, we have to gain the knowledge of allied angles and compound angles. Fifth unit, it is complex numbers. Sixth unit, introduction to calculus. In that, we learn about limits. So these are the 6 units we need to learn in engineering mathematics 1. So today let us start with the first unit, that is matrices and determinants. Why we need to study this chapter? What are the engineering applications? Where we use it? So this matrices and determinants very important in mathematics and also in engineering. So as we know that matrix will be used for making a simple method into a complicated one. So there are many complicated methods in solving the mathematical problem or engineering problem. They can be made into simple by using the concept of matrix. So this matrix is a Greek word. This matrix word was first used by a mathematician called J.J. Sylvester. J.J. Sylvester, he was used the word matrix first time. After that, later on, the famous mathematician called Arthur Cayley, he found many procedures in matrix. That is, it may be a addition, matrix addition, matrix subtraction, matrix multiplication, and other things. He was the pioneer of matrices. So this matrix will be very much useful in all the fields of engineering. If I take electronics, in electronics we have a mesh and nodal analysis problems will be there. So those mesh and nodal analysis problems will be solved in use of simultaneous equations. By solving simultaneous equations, we can get the unknowns. So that is the main application of the matrix, solving the simultaneous linear equations. If you take in computer science, so we use matrices in the changing three-dimensional images onto a screen as a two-dimensional one. That is very much important in graphs. It is very important in analyzing the graph. And also we study or we use the matrix in other fields like physics. Even it also applicable, it also usable in the field of economics also, right? So this is about a basic introduction to the matrices, right? So in the chapter matrix, we study how to add a matrix with the another matrix, how to subtract a matrix in the with the another matrix, how to multiply it, and also very important topic, we use these matrices in solving the simultaneous linear equations, right? To define a matrix, so I take you a case study. If I take information about SSLC students from various districts. So if example, Bangalore urban, how many boys are there, how many girls are there? Bangalore rural, how many boys are there, how many girls are there? So for example, 5,000, 550, 7,000 boys and girls. In Bangalore rural, say 6,000 and girls about 3,000, like that. If I take from all the district, we have a data. So how we have represented? We have represented data in the form of rows. In the form of rows, and also we can take them in the form of columns. They are what? They are the columns in which we have represented some data. So we can store the information in the form of rows as well as columns. So this helps in storing data of many information. So hence we can say that matrix is a rectangular arrangement of numbers. Rectangular arrangement of numbers, or we can say entries, which is enclosed in a bracket like big bracket or in parenthesis, or we can also use double bar. These are the symbols we use to represent a matrix. So I repeat it, matrix is a rectangular arrangement of numbers in the form of rows and column enclosed in the bracket like big bracket, parenthesis, small bracket and double bar. This is the definition of a matrix. So matrix is a rectangular arrangement of numbers in the form of rows and columns enclosed in the bracket. See, I will write you examples. Examples: A, B, C, X, Y, Z. It is a matrix. See the second example: P, Q, or S. It is another example of matrix. You can have any number of rows and any number of columns. Like that, this is also a matrix, right? See, the horizontal arrangement of numbers will be called as rows, and vertical arrangement of numbers are called columns. Is it clear? These are the rows and these are the columns. And X, Y, Z, A, B, C, they are all said to be entries. Entries are elements. Entries are elements of a matrix, right? Then, very important thing, order of a matrix. The order of matrix indicates in a given matrix how many rows are there and how many columns will be there. So this indicates what? Number of rows and number of columns. Number of rows and number of columns. Suppose a matrix is having m number of rows and n number of columns. How many rows are there? M rows. And how many columns are there? N columns. Then the order is stated as m by n. Order of a matrix is m by n, right? So order always indicates you how many rows are there and how many columns are there. You take the example, this one, first matrix. How many rows are there? First row, second row. There are 2 rows. And how many columns are there? First column, second column, third column. There are 3 columns. Hence, it is a matrix of order 2 cross 3. Right? Take this example. A, B, C. It is a matrix. It is a matrix. How many rows are there? Row 1, row 2, row 3. How many rows are there? 3 rows. How many columns are there? Only 1 column. Therefore, it is a matrix of order 3 cross 1. This is order of a matrix, right? Then we have different types of matrices. There are different types of matrices. The first matrix, row matrix. Row matrix is a matrix which will have only 1 row. Row matrix is a matrix having only one row. See the example: P, Q, R. It is a row matrix of order. What is its order? 1 row. How many columns are there? 3 columns. The order is 1 cross 3. Second one, column matrix. Column matrix. Column matrix is a matrix in which we have only 1 column. That is said to be column matrix. See the example: A, B. This is a column matrix. What is order? order is first row, second row. 2 rows are there. Order is 2 into how many columns are there? Only 1 column. It is a column matrix. Third one, null or zero matrix. Null or zero matrix. It is always denoted by O. Null or zero matrix is a matrix in which all the elements are equal to zeros. Null or zero matrix is a matrix in which all elements are zeros. All elements are zeros. See the example: 0, 0, 0, 0. 0, 0, 0, 0. This is a null matrix. The next matrix is square matrix. Square, how it looks? Length and breadth are same. In the same way, here also we have a equal number of rows and equal number of columns. Such matrix is called as square matrix. Square matrix. Rows are equal to columns. Such matrix is called square matrix. Example: 1, 5, 3, 2. Take another example: 5, 4, 3, 2, 1, minus 6, 3, 7, 8. In the first matrix, we have 2 rows and 2 columns. In the second matrix, we have 3 rows and 3 columns. Then its order is 3 cross 3. Its order is 2 cross 2. Next one, diagonal matrix. Diagonal matrix. You take a square matrix. See the above one: 1, 5, 3, 2, in which the elements lie along the diagonals. They are said to be diagonal elements. They are the right diagonal element and they are the left diagonal element. These are the right diagonal, or we can also call principal diagonal elements. These are the secondary diagonal elements. Principal diagonal elements. It is nothing but what? The elements which lie along the diagonal. The diagonal is started from first to which is moved from right. Hence it is called what? Right diagonal elements. Diagonal matrix is a square matrix. Diagonal matrix is a square matrix in which all the elements except principal diagonal elements are zeros. Except these elements, if other elements are equal to 0, such matrix is called as diagonal matrix. Say this example: 4, 0, 0, minus 15. Minus 10, 0, 0, 0, 2, 0, 0, 0, 5. Have a look on these two matrices. The first matrix, except principal diagonal elements, other elements are what? They are 0. Hence it is what? Diagonal matrix. Except principal diagonal elements, other elements are what? They are equal to zeros. Hence it is a diagonal matrix. Next one, scalar matrix. Scalar matrix is another type of matrix in which we can say this is a diagonal matrix. Scalar matrix is a diagonal matrix in which all the principal diagonal elements are same, which are equal. See this example. If it is 2, 0, the principal diagonal element should be 2 only. Minus 7, 0, 0, 0 minus 7 0 0 0, it should be a minus 7. This is a principal. These principal diagonal elements are what? Same. Other elements are what? 0. Here also, principal diagonal elements are same, which are identical. Other elements are what? Which are 0. They are the scalar matrix. Suppose in a scalar matrix, if all the principal diagonal elements are equal to 1, then that matrix is said to be unit matrix, or it is a identity matrix. Unit matrix or identity matrix, which is very important. Unit or identity matrix. It is always denoted by I. Unit matrix or identity matrix I. What is this? It is a type of matrix and which is always like similar to scalar matrix. In the scalar matrix, if all the principal diagonal elements are equal to 1, that is said to be identity matrix. See the example, I is equal to 1 0 0 1. Check this. Except principal diagonal elements, all are zeros, and see principal diagonal elements are what? Which is they are equal to 1. In 3 cross 3, see 0 1 0 0 0 1 0 0 0 1. This is a unit matrix. Now we have these different types of matrices. I repeat you, a row matrix. What is row matrix? Matrix is having only one row. A column matrix. Column matrix is what? It is a matrix in which we have only one column. Null or zero matrix. It is a matrix in which all the elements are equal to zeros. Square matrix in which it is a square matrix is a matrix in which the number of rows and number of columns must be equal to zeros. Then diagonal matrix. It is a square matrix in which all the principal diagonal elements are same and other elements are equal to zeros. Scalar matrix. It is a diagonal matrix in which all the principal diagonal elements are same, equal. And identity matrix or unit matrix. It is a scalar matrix in which all the principal diagonal elements are equal to 1. These are the types of matrices. Next topic, we can move to algebra of matrix. Algebra means it is nothing but addition, subtraction, multiplication. Okay. How we can add two matrices, or how we can subtract a matrix in another matrix. That is matrix operations. All these matrix operations were explained by a mathematician called Arthur Cayley. Matrix operations. First one, scalar multiplication. Scalar multiplication of a matrix. Scalar means a constant. A constant can be multiplied to a matrix. It is known as scalar multiplication of a matrix. Let us take K is any constant. K is any constant. A is any matrix. K is any constant and A is any matrix. If I take K into A, will be called as scalar multiplication. Scalar multiplication. So after scalar multiplication, you will always get a matrix whose order is always equal to order of A. Then how to get scalar multiplication? See, A is a matrix which will have number of rows and number of columns. In every row and every column there will be an element. Okay. K is what? It is a constant. It is a numerical value. How to get Ka? All the elements of A must be multiplied with K. That is called scalar multiplication. I will explain with example. See, A is a matrix 5, 2, 3, 1, minus 2, minus 7. If they ask find 2A, if they ask find 2A, they may ask you anything. 5 into A, 10 into A, 4 into A, like that. Suppose if they ask find 2A, 2 is a scalar, like K. A is a matrix. Then how to get K? We need K, right? Take K. K is what? 2. K is what? It is 2. Write 2 first. Then what is it? A. We have A. Write A. What is A? 5, 2, 3, 1, minus 2, minus 7. Right? Each element of the matrix A should be multiplied with 2. That is 2 into 5, 2 into 2, 2 into 3, 2 into 1, 2 into minus 2, 2 into minus 7. We multiplied all the elements of a given matrix with 2. Then it is equal to what? It is always equal to 2 into 5 is 10, 2 into 2 is 4, 2 into 3 is 6, 2 into 1 is 2, 2 into minus 2, it is minus 2, minus 4, and 2 into minus 7, it is minus 14. This is the procedure to get a scalar multiplication. Okay, take a second example. If A is equal to 1, 5, 2, 3, find A by 5. A by 5. A by 5. A is a matrix. 1 by 5. 1 by 5 is what? It is a scalar. See, A by 5 can be taken as 1 by 5 into A. That means each element of matrix must be multiplied with what? 1 by 5. Or each element of matrix A should be divided with what? 5. That is 1 by 5, 5 by 5, 2 by 5, 3 by 5. Right? Here 5 get cancelled. What is remaining? It is 1 divided by 5, 1, 2 by 5, and 3 divided by 5. You got this scalar multiplication. So I repeat it. Scalar multiplication is nothing but all the elements of a given matrix must be multiplied with a given constant. That's all the scalar multiplication. Okay. See, we have a matrix A. What is its order? Its order is what? 2 cross 3. 2 rows and 3 columns. After scalar multiplication, we got another matrix, right? What is its order? Its order is also equal to order of A. We have said 2 rows and 3 columns, right? Next, let us move to addition of matrices. We can add a matrix with another matrix. Addition of matrices. To add matrices, There are certain conditions. Let us take A is a matrix and B is a matrix. To add AB, to get AB, we need certain conditions. What are the conditions? Number of rows and columns of A must be equal to number of rows and columns of B. It means what? A and B should same order. A and B should have same order. After multiplication, what you will get? You will get another matrix. Its order is always equal to order of A or order of B, because order of A and B are one and the same, right? To add the two matrices, their order should be same. How to add it? So addition is taking place between the corresponding elements of A and B. What is the meaning of corresponding elements? It is positional correspondence. Suppose A is some matrix. See the example: 5, 3, 2, 1, 7, 4. B is another matrix. It should be same order of A only. Elements may be different. 2, -1, 3, 7, -15, 10. Can we add these two matrices? Definitely we can add them, because their orders are same. How to add them? See, in A, first row, let us take first row. In first row, what is first element? A. In B, take first row. Which is first element? 2. For 5, 2 will be the corresponding elements. For 3, -1 will be the corresponding elements. For 2, 3 will be the corresponding elements. You got it? The meaning of corresponding elements. Corresponding means their positions. Positions. First row, first element. First row, second element. First row, third element. Then A plus B is taking like this: 5 plus, I will write A, then what is symbol? Plus, then B, I will write B, then carry on the addition. 5 should be added with corresponding elements of the other matrix, that is 2. 5 plus 2. Next, 3. 3 plus into minus. The element 1 is having minus sign. That is multiplied with this. 3 plus into minus. -1. Third element in the first row. 2 plus 3. 2 plus 3. Next, in first row, all the elements are added with corresponding elements. Then we should move to the second row. 1 plus 7. 7 plus into minus. See, element 15 is having minus sign. So that minus and this plus will become minus. 7 minus 15. 4 plus 15. Then take addition or subtraction according to the sign. 5 plus 2. Both are having same number. It means we should add them. That is 7. 3 minus 1. Both the numbers are having opposite sign. Then we have to go for subtraction. Take the difference of 3 and 1 and carry the sign of the bigger element. The sign of bigger element is what? Plus. 3 minus 1 is 2. 2 plus 3 is same sign. Add them. Same sign. Add them. Opposite sign. Take the difference. Difference is what? 8. What is the sign in the answer? -8. Because we have to take the bigger element sign in the subtraction. 4 plus 15. It is 19. This is called addition. You got it? Addition means to add the two matrices, their order should be same. And how addition takes place? It takes place between the corresponding elements. Corresponding elements. We have given an example. Okay. In the same way, we can go for subtracting one matrix in the another matrix. To subtract a matrix in another matrix, we have to follow the same procedure. Subtraction. To subtract a matrix in another matrix, their order should be same. Their order should be same. After subtracting, you will get another matrix. The answer is what? Answer is another matrix whose order is what? Order is equal to A or order of B. Then how to subtract? It is similar to addition only. If I want to get A minus B, it means the element B will be subtracted with the element of A according to corresponding positions, right? I will take same example. A is what? It is 5, 3, 2, 1, 7, 4. B is what? 2 minus 1, 3, 7 minus 15, 10. The order is same, then subtraction takes place. Subtraction is A minus B. Write A, 5, 3, 2, 1, 7, 4. Minus, we have symbol negative, put minus. Then write B, 2, minus 1, 3, 7, minus 15, 10. Subtraction of the elements of B in elements of A. 2 is subtracted with what? 5. That is 5 minus 2 corresponding elements. 3 minus of minus. Is it right? This is a minus 1, hence it is this minus and this minus should be multiplied. Okay. 3 minus of minus. 3 minus of minus 1. 2 minus 3. 2 minus 3. 1 minus 7. 1 minus 7. 7 minus of minus 15. 7 minus of minus plus 15. Okay. 4 minus 10. 4 minus 10. You can write directly. So, to understand clearly, I am writing everything. Right? What is answer? 5 minus 2 is 3. 3 plus 1, it is 4. 2 minus 3. Minus sign is there. Opposite signs are there. Take the difference. It is 1. We have to carry the bigger number sign. 1 minus 7. Here also minus 6. 7 plus 15. It is 22. 4 minus 10 is minus 6. This is the subtraction. Okay, we got the operation addition and subtraction. In addition and subtraction, we have certain rule. Take them as a note. First one, if I take A plus B and B plus A, they will be always same. A plus B is always equal to B plus A. If I take A plus of B plus C, that is also equal to A plus B plus of C. But A minus B is not at all be equal to B minus A. Because A minus B is equal to A plus of minus B. You are not getting A minus B and B minus A are same. Then let us move to another operation. Transpose of a matrix. Transpose of a matrix. Transpose of a matrix is nothing but changing rows into columns or columns into rows. Changing rows into columns are columns into rows. That is called as transpose of a matrix. It is always denoted by, suppose if I make a transpose for matrix A, it is always denoted as A T or A dash. A dash. See the example. A is equal to some matrix X, Y, Z, P, Q, R. Then transpose means changing rows into column X, Y, Z, P, Q, R dash. Finally, you will get first row is what? First row elements are X, Y, Z. They should be taken as elements of first column. That is transpose. X, Y, Z. X, Y, Z. Second row is what? P, Q, R. P, Q, R is second row, which is represented in second column. Note a point. If I take n into A transpose, what is n? N is any number. It is always be equal to n into A whole transpose. Here we take transpose first and which is multiplied with some constant. Some answer will be obtained. Okay. Instead of doing that, if I multiply the constant first and then it is transposed, you will get the same answer. Right? Second note, A plus B whole transpose is always equal to B transpose plus A transpose or A transpose plus B transpose. Third point, A minus B whole transpose is equal to A transpose minus B transpose. These are some of the notes about transpose, addition and subtraction of a matrices. Right? Based on this, we have another phenomena that is equal matrices. Another concept, equal matrices. Equal means same. If I take two matrices, if they are similar in corresponding elements and the order, then they are said to be equal matrices. Right? Example, A is equal to some matrix 2, 3, 1, 5. B is equal to 2, 3, 1, 5. What is order? A and B are having same order. Okay. See the corresponding elements 2, 2, 3, 3, 1, 1, 5, 5. They are same. Definitely A is equal to B. No doubt. Because orders are same, corresponding elements are also same. Equal matrices are nothing but what? One matrix is the mirror image of another matrix. Such matrices are said to be equal matrices. You see the another example, second example. A is equal to A, B, X, Y, P, Q. There is another matrix B, 1, 5, 2, minus 3, 7, minus 6. Can you call A and B are same? Definitely. By looking into them, we can say no. Why? In the first row of first matrix, A, B, Q is P is there. In the second matrix, orders, the elements are not same. Here it should be A, here it should be B, here it should be P. Okay. Basically, A is not equal to B. Suppose if you want to make them equal, then what condition you can put? If these two matrices are not same, if you want to make it same, then what condition you can put? See, but A is equal to B, A is equal to B under the condition of what? If A is equal to 1, B is equal to 5, P is equal to 2, X is equal to -3, Y is equal to 7, Q is equal to -6. Is it right? Basically, they are not same matrices, equal matrices. But if you want to make them equal, then you can give a condition. If A is equal to 1, B is equal to 5, P is equal to 2, X is -3, Y is 7, Q is -6. They are said to be equal matrices. Okay. These are some of the basic operations. Apart from that, there are other operations, multiplication of two matrices, that will be taken up later on. Let us work out few problems based on these equal matrices, addition, subtraction, scalar multiplication, and also on transpose of a matrix, right? First example, if A is equal to 1 pi 3 minus 2, B is equal to 4 minus 6, 3, 2. Find A plus A transpose. Second one, A transpose minus A. I have taken two matrices A and B. I need to find out few procedures. A plus A transpose minus A, 3A minus 2B, fourth one, 5A plus 3B. Let us work out one by one. What is first one? First one is A plus A transpose. To write the matrices according to given expression. What is that? A plus A transpose. What is A? Take this. 1, 5, 3, minus 2. Then what symbol we have? Plus, put plus. Then what it is there? A transpose. What it mean? In A, rows are changed into columns. Correct? First row is made as first column. Second row is made as second column. This is the A transpose. Then what we need to do it? We need to add the matrices 1 plus 1 corresponding elements. 5 plus 3, 5 plus 3, 3 plus 5, minus 2, plus into minus, minus 2. Then what is answer? 1 plus 1 is 2, 5 plus 3 is 8, again 5 plus 3, 8, minus 2, minus 4. So when we have a same sign with the numbers, then we should add them. Minus 2 is minus 4. What is second expression we need to calculate? A transpose minus A, right? Second one, A transpose minus, we have to calculate. Right, A transpose minus A. What is A transpose? Change the rows into column. 1, 5 is first row, that is made as first column. 3 minus 2 is second row, which is made as second column. Okay, this is A transpose. Next, what we have? Minus. Then what we have? A, write A. What is A? 1, 5, 3, minus 2. According to the symbol, you simplify it. We need to subtract this in this. Answer is what? 1 minus 1. 3 minus 5. 5 minus 3. Minus 2, minus into minus, plus. Minus 2 plus 2. 0, minus 2. This is 5 minus 2 is 2 and this is 0. Right? Second expression we got it. What is third one? We have to calculate 3a minus 2b. Third one, we have to calculate 3a minus 2b. 3a minus 2b. Listen. 3 into, what is a? You write a. So what we need to calculate, you write according to that and perform the procedure. Okay. 3a minus 2b. Just write 3, then write a. What is a? A is 1 by 3 minus 2. 1 by 3 minus 2. Then what is symbol? Minus. Then 2 into b. What is b? See, 4 minus 6 first row, 3 to second row. Now, what we need to do? We have to multiply 3 with all the elements of first matrix. Then multiply with 2 of next matrix. Okay. This is what? 3 into 1, 3. 3 into 5, 15. 3 into 3, 9. 3 into minus 2, minus 6. Minus, I have written minus. Then what is remaining? After writing minus, remaining is what? 2 into the matrix. You just multiply all the elements with 2, not with minus, because I have carried minus here. Okay. 2 into 4 is what? 8. 2 into minus 6, minus 12. 2 into 3, 6. 2 into 2, 4. Then 3 minus 8. 15 minus of minus plus 12. 15 minus of minus plus 12. By writing in splitted way, you can write the answer directly. It has minus 5, it has 27 like that. 9 minus 6. Minus 6 minus 4. Minus 6 minus 4. The answer is what? The answer is minus 5. It is 27. 9 minus 6 is 3 minus 10. This is 3a minus 2b. Next expression we have to calculate is what? 5a plus 3b. 5a plus 3b. Fourth one, 5a plus 3b. 5a. Write 5. Then write a. What is a? A is 1. 5, 3 minus 2. Next symbol. We have plus. Write 3 into b. What is b? 4 minus 6. 3, 2. Scalar multiplication. 5 is multiplied with all the elements. That is 5 into 1, 5. 5 into 5, 25. 5 into 3, 15. 5 into minus 2, minus 10. Okay. Then put plus. Multiply with 3. 3 into 4, 12. 3 into minus 6, minus 18. 3 into 3, 9. 3 into 2, 6. Now add the corresponding elements, which is equal to 5 plus 12. 5 plus 12. 25 plus into minus, minus 25 plus into minus, minus 18. 15 plus 9. 15 plus 9. Minus 10 plus 6. Minus 10 plus 6. So its answer is equal to 5 plus 12. It is 17. 25 minus 18. It is 7. 15 plus 9. It is 24 minus 10 plus 6 is minus 10 plus 6 is minus 4. This is the answer. Okay. Let us take one more example. Second example. If A is equal to 1, 5, minus 7, 2, 3, 8. Take B. B is equal to 6, minus 3, 2, 1, 4, 5. Find 3A minus 2B whole transpose and 5A transpose plus 3B transpose. Let us work out one by one. First we have to calculate 3A minus 2B whole transpose, right? First one, 3A minus 2B whole transpose. I cannot get 3A minus 2B whole transpose first, right? Directly, I cannot calculate it. Basically, get 3A minus 2B first. Afterward, we need to transpose it. Okay. This is the required one. First, calculate 3A to 2B. Right, according to the equation, 3 into A. What is A? 1, 5, minus 7, 2, 3, 8. Then minus of 2 into B. Write the B. What is B? 6, minus 3, 2. First row, 1, 4, 5. Second row. This is equal to multiply all the elements with the 3 into 1, 3 into 5, 15, 3 into minus 7, minus 21, 3 into 2, 6, 3 into 3, 9, 3 into 8, 24. Keep minus as it is. Multiply with 2. Minus of 2 into 6, 12, 2 into minus 3, minus 6, 2 into 2, 4, 2 into 1, 2, 2 into 4, 8, 2 into 5, 10. Then subtract second matrix in first. That is equal to 3 minus 12. 3 minus 12. Next, second elements in first row. 15 minus of minus plus 6. Minus 21 minus 4. Then second row elements 6 minus 2, 6 minus 2, 9 minus 8, 9 minus 8, 24 minus 10. Write the answer. 3 minus 12, it is minus of how much? 9. 15 plus 6, it is 21. Minus 21 minus 4. Signs, symbols are same. Then we have to add the numbers. Minus 25. 6 minus 2, it is 4. 9 minus 8, it is 1. 24 minus 10, it is 14. This is 3A minus 2B. Then we can calculate or we can write 3A minus 2B transpose. 3A minus 2B transpose. What is 2A minus 3A minus 2B? It is minus 9, 21, minus 25, 4, 1, 14 transpose, which is equal to what? Changing rows into column. First row is made as first column, minus 9, 21, minus 25. Second row is made as second column, 4, 1, 14. This is first expression value. Second one, we need to calculate 5 A transpose plus 3 B transpose. Okay, that we can calculate directly. Second one, 5A transpose plus 3B transpose. Okay, you write according to that expression. 5 into A. What is A? 1, 5, minus 7, 2, 3, 8. Transpose. Otherwise, you can write directly, changing rows into column. Plus 3 into B. B is what? 6, minus 3, 2, 1, 4, 5. Transpose. You just perform according to the equation. It will be easy. 5 into transpose it. Change the rows into column. 1, 5, minus 7, 2, 3, 8. Plus 3 into transpose it. 6, minus 3, 2. 1, 4, 5. In the next step, I need to multiply with 5. 5 into 1, 5, 5 into 2, 10, 5 into 5, 25, 5 into 3, 15, 5 into minus 7, minus 35, 5 into 8, 40. Plus, multiply second matrix with 3. 3 into 6, 18. 3 into 1, 3. 3 into minus 3, minus 9. 3 into 4, 12. 3 into 2, 6. 3 into 5, 15. Then go for addition. 5 plus 18. 5 plus 18. 10 plus 3. 25. Plus into minus, minus 9. 15 plus 12. Minus 35 plus 6. 40 plus 15. Finally, you will get 5 plus 18, 23, 10 plus 3, 13, 25 minus 9. It is 16, 15 plus 12. It is 27. Okay. 27, 35. It is minus 35, minus 35 plus 6. It is minus 29. 40 plus 15. It is 55. This is what 3A transpose plus, 5A transpose plus 3B transpose. I can take one more example to verify the property. If A is equal to 1, 5, 3, 2, B is equal to 4, minus 3, 7, minus 5, then show that A plus B whole transpose is equal to B transpose plus A transpose. So in this problem, I need to verify the property. What is that property? A plus B whole transpose is always equal to B transpose plus A transpose. Let us take left hand side. In left hand side, what we need to calculate A plus B whole transpose. So I cannot calculate directly. First I need A plus B. First get A plus B. What is A? 1, 5, 3, 2. Plus what is B? 4, minus 3, 7, minus 5. We can write directly addition, right? 1 plus 4. Instead of writing expanded way, you can write directly also. 1 plus 4 is 5. 5 plus into minus, minus 3. 5 minus 3 is 2. 3 plus 7, it is 10. 2 plus minus 5 is minus 3. This is what? A plus B. Therefore, left hand side is what? A plus B whole transpose is equal to what? First row is made as first column. 5 to first column. 10 minus 3 become second column. It is transpose. Left hand side A plus B whole transpose. Then I need to get what? Right hand side. What is right hand side? B transpose plus A transpose. What is B transpose? What is B? B is 4 minus 3 first row, 7 minus 5 is second row, which is made into changing rows into column. I will write directly 4 minus 3. That is first row is made as first column B. Second row is made as second column 7 minus 5. Next plus write directly A transpose. This is A. A transpose is what? 1, 5, 3, 2. That is equal to 4 plus 1 is what? 5. 7 plus 3 is what? 10. Minus 3 plus 5 is what? 2. Minus 5 plus 2 is what? Minus 3. See, the left hand side and right hand side, they are one and the same. Hence the property. Hence the property. A plus B whole transpose is equal to B transpose plus A transpose. Suppose you are not getting same thing. It means what? You have done mistake in the procedure. You have to go back and check the problem. Okay. It is always true. The properties are always true. Sometimes the problems will be given like this. If A plus B is equal to 5 minus 4, 3, 2 and A minus B is equal to 6 minus 7 minus 4, 3. Find A transpose and B transpose. Just see the problem. If they give the matrices A, B separately, then it is easy to calculate A plus B transpose or A minus B whole transpose or 2A minus 5B like that. But here, what they have given? They have given A plus B is a matrix, A minus B is another matrix. With that, we have to calculate A and B and their transpose. So if they give like this, what to do? Treat them as simultaneous equations. This is the first equation. A plus B is equal to constant. A minus B is equal to constant. Solve them as a simultaneous equations. See, I write like this. A plus B is what? It is 5 minus 4, 3, 2. First equation. Second equation is what? A minus B, which is equal to what? 6 minus 7 minus 4, 3. This is second equation. How to solve two simultaneous equations? As we know, at the high school level, if they give like this, x minus 2y is equal to 4, x plus 5y is equal to 7, to cancel x, if they have same coefficients of x, then we make addition or subtraction according to the sign. If they are having same sign, we are going to subtract. If they are having opposite sign, we are going to add. Right here, plus plus, we are going to subtract. Then we will get what? Minus 2y minus 5y. It is minus 7y. Minus means 4 minus 7 is minus 3. With this, we get what? Y. By substituting y, we will get the x. In that way, we have to calculate A and B. First, before adding or subtracting, you check the coefficients of matrix A and B. Here we have same coefficients x, A plus B and A minus B. We don't have coefficients of A and B, right? Then you can add or we can subtract. Suppose if you want A, you need to cancel B. If you want B, you need to cancel A. So first I want to cancel B. Then they are having opposite sign. This is plus B, this is minus B. I'm going to add them. Right? If I add these two, these get cancelled. A plus A is 2A. I did addition at left side. At the same time, if I have to add at the right side, this matrix should be added with this. Means what? 5 plus 6, 11, minus 4 plus of, because we are adding at left side and right side. 5 plus 6, 11, minus 4 plus into minus, minus 7, it is minus 11, 3 plus into minus, minus 4, it is minus 1, 2 plus 3, it is 5. Clear? Then take A. What is A? A means cross multiplication. 2 is goes to denominator of whole matrix. That means it is 1 by 2 into 11 minus 11 minus 1, 5. Therefore, which is equal to A is equal to 11 by 2 minus 11 by 2 minus 1 by 2, 5 by 2. It is A, right? We need A transpose. Just make it transpose. A transpose is equal to what? Changing rows into column. First row is made as first column. Second row is made as second column. See, minus 1 by 2, 5 by 2. To get B, you need to cancel A. Okay. How to cancel A? Take the same equations. A plus B is equal to what? 5 minus 4, 3, 2. A minus B is equal to 6 minus 7 minus 4, 3. Here, if I add it, B get cancelled. Suppose if I subtract left hand side and right hand side, A get cancelled. Plus A minus A cancelled. Plus B minus of minus what? Plus, it become what? 2B. I need to subtract on both the sides. Okay. Plus A minus A cancel. Plus B minus of minus. Plus B become 2B. Now I need to subtract this second with the first. 5 minus 6 minus 1 minus 4 minus of minus plus 7. It is 3. 3 minus of minus plus 4. It is 7. 2 minus of 3 minus 1. This is B. Therefore, B is equal to what? Minus 1 by 2, 3 by 2, 7 by 2, minus 1 by 2. Hence, what is B transpose? In B, we have to make the rows into column. Minus 1 by 2, 3 by 2. First row is made as first column. Second row is what? 7 by 2 minus 1 by 2, which is made as second column. This is B transpose. So these are some of the important problems related to your exams. We have worked out problems on addition, subtraction, scalar multiplication, and other things. Okay. So with this, I conclude my today's class. If you have a doubt, please ask me the questions. So as and when you ask the questions more and more, then it will be clear for you.